Hello everyone, welcome to this video. Myself Ananjay Pampali, and today I'll be diving into the world of data structure where I'll be explaining about binary trees. So we will be going through the different operations that can be done such as insertion, deletion and traversal techniques, and finally we will write a Python code where I'll be implementing these operations. Now let's begin with the video. So what is a binary tree? A binary tree data structure is a hierarchical nonlinear data structure in which each node has at most two children. That is, each node can only have two children, cannot have more than two. So it is referred to as uh, each of the children are referred to as the left child and the right child. It is binary tree is commonly used for efficient storage and retrieval of data with various operations like insertion, deletion, and traversal. Binary trees are powerful for efficient searching, sorting, and hierarchical organization. Now let's draw a simple binary tree. This- so this is the simple binary tree. So this node over here is called the root node. So a root node is the first or the topmost node that is present in a tree. Now in a tree there is always only one root node. This node is called the left child and this node is called the right child. So like if we create a similar thing over here as well. So this part of the tree is called the left subtree and this part of the tree is called the right subtree. A node which does not have a child is known as the leaf nodes. So these four nodes over here is known as the leaf nodes in this particular binary tree. The height of the tree is the number of vertices in the tree from the root to the deepest node. So in this tree, from the root of the tree to the deepest node, which is one of these node is the deepest node. So 2 is the height of the tree because there are two edges going through from the root to the child, the deepmost child. Now let's move on to the operations that can be done in binary tree. The first one is insertion in binary tree. We can insert a node anywhere in a binary tree by inserting the node as the either as the left side or the right side of any node, or we can make the node as the root of the tree. Now, if you have to create an algorithm for insertion in binary tree, the first step would be to create a new node with the data or and make it the root. This step is if the tree is empty. Otherwise, like if we already have a tree with like we have over here, uh, we need to compare the data to be inserted with the current node's data. Now let me modify this binary tree and add some data. So suppose we have data as 4 here, 5 over here, and 6 over here. Now, if that if the data which we need to insert is less than the node, we have to move it to the left child and call insert. And if it's more than if the data which we need to insert is more than the current node, then we need to uh, move it to the right child. So, for example, if the new data which we need to insert is the number 1, then we have to give it to the left side over here. We give the data 1 over here. Now, if we need to add the data 7, the number 7, 7 is more than 4 over here, so we need to give it to the right side. 7 will come in. So that's how the insertion works. Now, once we reach an empty spot, which is a leaf node is a node which does not have any child. So once we reach an empty spot, we create a new node with the data and assign it as the left or right side of the current node. So that's all for insertion. Now we move on to the second operation, which is deletion in binary tree. We can delete any node in a binary tree and rearrange the nodes after deletion to form a valid binary tree again. So removing nodes requires handling different scenarios. So if we have a data to be which have to be deleted, so to do so, we first need to search for the node with the particular data. And if that node is not found, it returns that the data is not present. So here, for example, if we need to delete the data the node which has the data number 2, number 2 does not exist in this binary tree, so the it will return that the data is not present. The second case is if the node is a leaf node, that is a node which does not have any children, we can simply remove it easily. So in this example, the nodes with data 1, 7, and 6 are leaf nodes. So these three nodes can be easily removed. Now, the third case is if the node has one child, we promote the child to take its place. This means that let's modify the table. This Now this node has only one child. So if we need to delete the this node from the binary tree, we can just promote the child to its parent's position. So our final binary tree will be become like this. This is how the final tree would become. Now, if the node has two children, we find the smallest node in the right subtree and replace the node to be deleted with the smallest node in the right subtree and delete the particular node. So that's with the deletion of binary tree. Now let's go to the next operation, which is traversal in binary tree. The traversal of binary tree involves visiting all the nodes of the binary tree. So there are mainly three traversal techniques, which are in order, pre-order, and post-order traversal. So these traversal methods visit the nodes in a specific order, which can be useful in different applications. So the first technique is in-order traversal. In this technique, we first visit the left subtree completely, which includes all nodes under the left child. Then we visit the root node, and finally we visit the right subtree completely. So in this example, let's take the previous binary tree. So in this example, we first traverse through the left subtree, which is this part of the binary tree. Uh, then after that, we visit the root node of the tree, and then we go on to the right side of the right subtree of the binary tree. So this in-order traversal is particularly useful for the binary search trees So binary search tree are similar to binary trees, but they have an order in which for each node, all elements in its left subtree are less than the node, and all elements in the right subtree are greater than the node. Now, the next traversal technique is the pre-order traversal. So, in this technique, we first visit the root node, then we visit the left subtree completely, and then finally we visit the right subtree. So, pre-order traversal is often used when creating a copy of the tree structure. So, and by visiting the root first and then its children recursively, we can replicate the original tree's hierarchy in a new structure. Now, the final the last technique for traversal is post-order traversal. So, in this traversal, we first visit the left subtree completely, and then we move to the right subtree, and finally, we visit the root node of the binary tree. This post-order traversal is used in scenarios where we need to process child nodes before the parent node. For example, if we want to delete a node in a tree, we have to delete its children first before removing the parent node. So post-order traversal ensures that we visit the child nodes first. So that's all about the traversal techniques. Now, since we are done with the operations of binary trees, let's move on to the coding part where I'll be implementing all these operations into a binary tree. So let's begin by creating a class called TreeNode. And inside this class, we define any self comma equals key self dot left equals none and self dot right equals none. So this is to initiate the class. Now next we define insert as root key. So here we have many cases. The first one is if root is none, return tree node key. Else if key greater than root value, root dot left equals insert root dot left comment. Else dot right equals insert root dot right comma key. So this function is to insert a new node with the given key into the binary tree rooted at root. And if the tree is empty, it creates a new node with the given key as it's given over here, this one's. And if the tree is not empty, then it recursively traverses the trees to find the appropriate position to insert the new node based on the key. Now, next we have define delete root key. So here also we have many conditions. The first one is if root is none, return root. If key greater than root dot val. Root dot left equals delete root dot left comma elif key is greater than root value, then root dot right equals delete root dot right comma key. Then we have else if root dot left is none, then equals root dot right equals none, and we return 10. Elif root dot right is none, temp equals root dot left equals none, and we return temp. Now if the temp is the minimum value node, dot val equals temp dot val. Root dot right equals delete root dot right comma root comma templates. And finally we return. So this function is used to delete a node from the binary tree. Now what this function does is that it first searches for a node with the given key, and if the node is found, it can be deleted in three cases. So the first case is that if the node has no children, then the function can simply remove it. If the node has one child, it replaces the current node with the child with its child. Now, if the node has two children, it finds the in-order successor and it copies its value to the node to be deleted and delete the in-order successor. Next, we have to define the minimum value node. Current equal node. Then we start a while loop here. Since while current dot left is not none, then current equals current dot left. Then we return current again. Now the next function is the three types of traversal. The traversal techniques, which are in order, pre-order, and post-order. So let's start with the in order. Define in order root. If root in order root dot left, then we print root dot value n equals, so in order root dot right. So here the first we go through the left of the root, then we have the root value, and finally we go to the right of the root, right part of it. Now the next one is pre-order. So we define pre-order root. So if root print dot root dot val equals, then we give pre-order root dot left and pre-order root dot right. So here first we go to the root value, which is the for middle node. Then we go through the left of the root and finally the right of the root. And finally we have to define the post order traverse. Now if root, we have post order root dot left, post order root dot right, and finally we have to print the root value. And yeah, so these are all the functions that are def which are the operations for binary trees. Now let's move on to an example where we can implement these operations. So first of all, we start with creating the root. Now we insert values into the root with insert function. So insert root comma 50. Root equals insert root comma 30. This is copy this. So we can insert as many numbers as we want. So I will be 9, 40, 70, 50, 30, 20, 40, 70. And we can give 60 and 80 as well. Yeah, so we insert all these numbers into the binary tree. Now let's print the in order transversal. Traverse is in order bracket root. Now when you run this code, as you can see here, it has been arranged in the ascending order, which is 20, 30, 40, etc. So this is the in order traversal. Now let's move on to the next operation, which is reorder traversal. So reorder traversal, we can give reorder. Now when we again run this code, you can so you can see that the pre-order transversal has come in this order, which is 50, 30, 20, 40, 70, 60, and 80. So this means that the binary tree has been traversed in the following way. Now next we have the post order traversal. Post order traversal. is post order of food. Now, when we again run this code, as you can see, the post order traversal has come in this way, which is 20, 40, 30, 60. So this is how the binary tree will be traversed when it is traversed in the post order technique. So now let's try out the delete function. So when to delete, suppose we delete the data of 20, we delete root equals delete root comma 20. When we print the in order, let's say we print the in order traversal again. We can here in order traversal after deleting 20, we can give in order of. So here we have set the root to we have changed the value of root to, and we have deleted the data 20. Now we have a new root which we are going to. Now when we run this code, we can see here in order traversal after deleting 20 is 30, 40, 50, 60, 70, and 80. This means that the number 20 has been deleted from the binary tree. So that's all about the binary tree and the operations of binary tree. We have also seen how we can implement these into Python code. So hope you guys have understood what is binary tree and all of its operations. So, and thank you for watching.